Hey, everybody. Welcome to the Data and AI World Tour. My name is Arsalan Tavakoli. I'm one of the co-founders here at Databricks and run our field engineering team globally, and super excited to be here with you today. So let's first start with why have we all gathered, right? There's this notion, we look at these set of companies that are completely disrupting industries, right? You talk about the Netflixes of the world, the Metas of the world, the basically Apples, Microsofts, Googles of the world. How are they doing it? They've discovered this notion that three things that have historically been distinct from each other, which is data, analytics, and AI, by bringing them together, they could power something revolutionary that allows them to achieve this disruption. Now, if we take that and fast forward, we see that in 5 years, every company will be defined by data, analytics, and AI. Because the reality is that those who are able to embrace it will evolve and be successful, and those who are not, won't be successful. Many of them may not be, around. Now, as we look at this, we talk about this notion of the data-defined enterprise, right? Data, analytics, and AI. They're a little bit of a abstract, concept. So let's talk about, from a business perspective, what that actually means. So one, we look at from a customer engagement perspective. The notion is that now enterprises are able to bring this relevance and hyper-personalizations to every touch point to deliver unique and enhanced services for their customers. Two, from a product perspective, we're able to take predictability and precision around it to basically build far better products. Three, we look at it from a workforce perspective of having all of this data and real-time insights allow us to drive much greater productivity and effectiveness. And then last but not least, from a business operations perspective, how do we use this combination to drive far more efficiency and maximize profitability as well? So these are from a business problem perspective, and this sounds great, but what does this mean in practicality? You look at it as we talk about this data, analytics and AI maturity curve. Most organizations start here on the left, which is more in the category of understanding what happened, right? How did my sales department do? How many products did I ship? What did customers do? But then what they want to start getting is to influence the future, understanding, well, what will happen, right? How should we respond? And can we even get to the point that we are automatically making the best decisions or guiding the best decisions possible, right? Along this curve from going from what we say from hindsight to foresight. Now, if you look at this, they really get broken up into two categories. One, the left side is more the domain of traditional BI or business intelligence, as you're looking at cleaning the data and reports. And then the right side is this concept of AI and much more advanced analytics. And so, the notion is you need both, right? Not one or the other. It's like, how can you understand, and apply what happened in the past in order to be able to predict the future and affect the present, right? So now let's take some examples of organizations that have done this successfully. Rolls-Royce, that we're all familiar with, they've been able to take a bunch of their supplier data and streaming IoT sensor data from all of their devices. So we oftentimes think cars, but think cars, think engines, think plane, and to predict maintenance needs for over 13,000 airplanes and be able to increase the lifespan of these jets. Because the key thing about predictive maintenance is being able to understand a problem is going to happen beforehand and address it proactively is far more effective and more cost effective than finding out after the fact. And they now look at it as a result of this, that they can point to having saved over 22 million tons of carbon emissions to drive this. Second, we look at Amgen in the health and life sciences space. And so they've taken all of this patient data and brought together to basically tons of these cross-functional, models that they have around analytics and ML and users that they're constantly looking at discovery in the health and life sciences space. And what they've seen is that they've been able to accelerate drug discovery and optimize costs of clinical trials, things that are historically very laborious, time-taking, and inefficient, and a little bit of a crapshoot, and be able to be far more precise around it. And they've shown that in their case alone, they've driven over 100 million in saved clinical trial costs. Okay. And then from a third perspective, we look at AT&T. Right. And what they've been able to look at and say, can we bring together two different worlds, like all of the customer data And then on the other hand, significant amounts of streaming events to drive all of these models that they're trying to understand. What is customers' behavior? How do we think about churn? How do we think about fraud? And so in this particular case, they've scored over 100 million transactions per day, whether it's in-store, whether it's online, or in their support center. And they can basically point to clearly the benefit that they've had over their 182 million wireless subscribers, that they've had a far better experience and been protected because of their ability to bring, again, data analytics and AI together at this scale. So these sound great. These sound amazing, right? Everybody wants to do this. But if we go back, the reality is that most organizations struggle because their systems don't support the goals, right? Whenever we look at it, there's obviously technology and people and process, but the technology ends up being a huge hindrance in many of these cases. Let's dig in to understand why. So first, we look at, data sits in the data lake. Over 90% of the world's data sits inside of a data lake. It's just become, for a variety of reasons, this kind of low cost, persistent, highly reliable data store that you could drive the data in. But the problem for most folks is that they're unable to drive value out of that. So they have to take multiple steps and bring multiple systems together. So first of all, the data that lands there is super raw. So now you have to find a way to clean it up, to transform it, to make it meaningful, and orchestrate that whole process with the data orchestrator. Next, we talked about that BI realm of the world. You're going to take it and copy subsets of data into another system, data warehouses, which are generally the repository for these last hop structured, pieces of data. Now you have some data sitting in a data lake and a subset of it sitting in a data warehouse. But guess what? In this world, we have to think about, how do we govern our data? How do we secure it? So now you're going to have two different distinct models. So already this is a bit hard to think about. The data warehouse is the domain of thinking about actual tables as the logical construct, while data lakes have been more around, more coarse-grained files and blobs. Now you have two different security models, which already make it difficult to synchronize and think about them. And then next is, what are you going to do with these, right? So now the data warehouse side is able to support business intelligence. And then on the other side, you get to it to say, hey, we'll have a separate system for data science and ML and real-time streaming. The problem with this is, nowhere did you hear me in the examples talk about, what, AT&T did this with a BI use case, or Rolls-Royce did this with a real-time streaming use case. They have end user use cases, and the problem is that they require access to all of the data and across all of these workloads, right? So you can just imagine the complexity that starts building up. But we're not done with this yet, right? Because the reality is that almost no organization sits on a single cloud. The reality is, I always like to say that there's three types of organizations: those who are multi-cloud today, those who are aggressively moving there, and those who are frankly either too ignorant or stubborn to admit that they're in one of the first two categories. So if you take that going forward and look at it, you say this whole complexity, well, now let's say that we have it on one cloud. I've now got to go and replicate this across multiple other clouds. So how do I keep these all in sync? And so some of the challenges that come out of this, right? One, you look at it and say, this is incredibly complex. You have multitudes of these workload-specific tools and technologies. It's how you end up in those places where they say we have 6 of everything or 7 of everything. Second, it's almost always the historical tools are proprietary, right? There's this notion that, hey, look, we're going to make it super easy to try to get data into this nice proprietary format. Ignore that over here, but now it's locked in. And so what about ever wanting to be able to get it out? What about collaboration? And then frankly, this notion that they're cloud specific. So great, you finally figured out, how you were going to solve the first 2 problems, but you did it for one cloud. Now you got to solve it again for another one. And then how do you figure out how do you interoperate between those? So as you might imagine, when we talk with organizations and enterprises, they ask for something far simpler. So they say, look, can we have it be simple? Can we have something be open? Right. And again, open is less about this notion of, hey, like I just want a couple of bits that are open or in a repository somewhere, but it's about, can we have something that people are rallying around, building standards around, other tools are integrating with, and there's a true ability to have portability down the line. And frankly, can we get this notion of being multi-cloud? And what I like to say is it's about being multi-cloud, cloud native. Right? You want something that from an end user perspective, you could pick one and they have a uniform experience across the clouds, but you want to deeply integrate with all the benefits that each of the cloud services provide as well. Okay. So with this concept of being simple, open, and multi-cloud, we get to this notion of a data lakehouse, right? As you might imagine, all of your data, analytics, and AI on one single platform. So let's look at how that might work, right? First, we start with kind of all of your data sitting in the lake, both structured and unstructured data across all of the major clouds. And so what do you need to make this successful, right? That it sounds great. I have one system to solve, everything, but what are the challenges of that? One, you want this notion of actually having unified data management. So as the data comes in, how do I think about things such as reliability, right, and versioning and performance and layout and core quality? So that's one big piece that you need. And then second, once you have that in place, you're worried from a governance perspective of how do you drive security and consumability? How do you make sure you know who's accessing the data, what data they're accessing, what do they do with it? And then how do you also make sure that all of the folks in your organization know how to find the data that they need? You make it easy for them to consume. And then finally, once you have these two at the core, the key part is how can we look at supporting all of the different workloads on top, whether it's from the more traditional BI and data warehousing through data engineering, data streaming, and data science and ML as well. Right? This unified support for all of the use cases. And so as you might imagine, what you get with Databricks embodies this vision. So what we refer to as the Databricks Lakehouse platform looks at these components. One, it builds with the lake first perspective. All of your data sitting on across any of those clouds, so having multi-cloud support. And then adding, when we talked about unified data management with Delta Lake, and then getting to governance around it being this notion of Unity Catalog. And then finally, having core parts of this unified platform that support everything from Databricks SQL for data warehousing, Databricks workflows for orchestrating ETL, Delta Live tables for building those real-time applications, and Databricks ML for the data science and ML piece as well. Now, you get this core platform which delivers those needs, but the reality is in any organization, there's never going to be, quote unquote, one ring to rule them all, right? Instead, you're going to have a huge ecosystem for a variety of reasons that you want to plug into. And that's what makes a platform be a platform. So when you look at Databricks as a core, it's no exception to that. And we've actually fully embraced that notion. So for all those different parts, whether you look at, from data ingestion and using things like Fivetran, and Matillion, to when you're looking at, data pipelines with DBT, lots of different governance and policy providers. And then across the whole spectrum, these tools all deeply integrate as first-class citizen. And then on top of it, you have a huge group of consulting and SI partners as well that are building vertical and domain-specific applications, whether it's across financial services or telco, public sector, or healthcare, to basically help accelerate organizations' ability to get to value quickly. So now as we look at it, why do we care about all these capabilities? Because it goes back to that first conversation that we had, right? Notion from this Databricks platform, you power those different classes of basically solutions we talked about, from customer engagement, product development, workforce experience, and business operations, without having to worry about underlying plumbing or multiple different systems or all of that complexity, or getting locked into something proprietary. Now, that's great. The lake house, it sounds super interesting, that we've talked about it. But why should we believe it? Why do we believe that this is on the right side of history? And look, my perspective is that notion when you walk to an organization and say, you know what, we can bring all these together with the platform that drives simplicity and being open and being, multi-cloud. Nobody sits there and tells me, you know what, that's a stupid vision. I would much rather have 6 of everything. The reality is that they say, yeah, that sounds great. Of course we'd want that, but you can't pull that off. Like, that's the reason we would have that. And I think that the key thing is that we've realized with some of these technologies that it's the time of the lake house has come, that it is now, a true basically reality. And one way of looking at that is that you can now see that the rest of the industry has taken notice. And many of these come from kind of other spaces, whether many of them come from more of the traditional cloud data warehouse world, realizing that no, the lake house model is the way to go. So just to give you some examples for you, right? You're looking at Microsoft has fully embraced the Lakehouse, where SQL DW has actually been, relabeled as Synapse, and all of their conversations are talking about how do we think about the Lakehouse, how do we make sure all the data sits in the lake in, basically Delta, and building this Lakehouse architecture. Similarly, you can go look at and say Google, which has often been this BigQuery-centric architecture from a data warehouse, seeing the same thing, now talking about the future is Big Lake, right? And having this concept of an open data lakehouse on Google Cloud, which is where they're seeing their customers take them. Or even going to, AWS, where traditionally it's been kind of more of a data warehouse from a Redshift-centric architecture, now talking about the way is putting all the data in S3 in an open format and looking at how do we govern it, and kind of many of their services looking to work with data directly in the lake instead of moving it into some proprietary format. And then finally, even if you look at, a Snowflake, which is, a fantastic cloud data warehouse, right, has realized that model of moving data into that proprietary walled garden just for running BI, doesn't necessarily work, that most of the data is going to sit in these open data formats in a lakehouse, and understanding that they have to support that and be able to read data directly there and figure out how their architecture needs to evolve for that. And you can even look at some of the more legacy players like Oracle, in Cloudera, who've talked about, the lakehouse being the future. So that notion is that the lakehouse is now viewed as being on the right side of history. It's the right architectural pattern. Great. So now everybody and their mother is going to come and talk to you about, a lakehouse, and we have a lakehouse. So how do we measure? How do we understand, how these different lakehouse offerings stack up? It's just like in the era of when big data started, everybody was a big data player. Well, benchmarks aren't the end all be all, but they do provide a good way for us to, understand, at least on one element, how folks perform against each other. And by the way, benchmarks are great, but it's also increasingly important for folks when they think about price performance in that. So what this looks at, this takes Databricks SQL versus all of the different major cloud data warehouses, and says, okay, we are going to run TPCDS as one example, and run it for all of the data sitting in Parquet. We haven't had any chances to move the data into a format, whether it's any of the cloud data warehouse proprietary formats or in, Delta Lake for Databricks SQL. And you could just see the difference between them. Because again, all of these cloud data warehouses, it's not about checking a box. They were all architected to work specifically in a very tight coupling of their compute and their storage on their proprietary data formats. So being asked to point to kind of a generic file format that sits elsewhere is not what they're particularly good at. And you could see this manifested in their costs. Now, you might say, you know what? That's unfair. We should allow them to even put their data into their data warehouse. Yes, you win on this, but doesn't this whole lakehouse concept give up a lot to actually those cloud data warehouses that have been spending, many of them, decades tuning for performance? And the answer is no. So if you look at this, test, which looks at it for pure data warehouse, which says, okay, we're going to look at the cost of actually loading it into their, systems, and then actually even allowing them to go in and do all of their different, clustering and optimizations that they do in the background and run the query, you could see it's a dramatic difference in basically the cost, between the two. And this is a, leading data warehouse. Now, even if you say, let's just ignore the other costs, which you can't, you have to pay, and just look at the query level, you see, even at the query level, Databricks is basically far less expensive than any of the other options. So that gives you the sense that not only is the lakehouse the way to go, but this is on one, when you look at it, that it can keep up with even the traditional styles of running data warehouses, but get all the benefits of a lakehouse going forward. So benchmarks are great, right? Everybody will say that their benchmark shows them, but what really matters is actual customer workloads. And so if we look at customer workloads, we could see a couple of these customers. So, Johnson & Johnson, a global healthcare company, talks about that they replace tons of their global data sources, streamlining supply management, retiring a lot of those data warehouses and data lakes to improve that inventory predictability. And you can see the benefit, how much faster they were actually getting the data, and just the sheer amount of cost reduction they were able to drive doing. Next, we'll go to Sam's Club, which is part of, Walmart. And they said, look, how can we bring, a bunch of that traditional supply chain data that's historically sat in our data warehouses, and bring streaming data from IoT sensors, whether it's in the stores or in the supply chain. And for them, it was a big deal, especially at the beginning of COVID, to say, how do we much more accurately forecast fresh food demand? At the beginning of COVID, everybody wanted, disinfecting wipes and flour, apparently. How do we get it in the right place? And you could just see the speed that they were able to get to insight, and the amount that they were to save annually through food waste was dramatic. And then finally, Atlassian. So anybody who has an engineering arm almost certainly has heard of Atlassian and Jira. And so they've looked at it of saying all of this data that they have, the telemetry data, the service data that they want to expose to all of their customers, to basically democratize this data and significantly lower their operational costs. And so you can see both from their analytics infrastructure costs and the speed that they were able to get this data to their customers was pretty impressive. Okay. So now we've looked at the benchmarks, the benefit of the Lakehouse. Let's talk about how we actually go about building the Lakehouse, right? And for that, we can double click on some of the major pieces, specifically at the governance level, right? So we talked about the Databricks Lakehouse platform. Let's talk about Delta Lake and what it is and why it's interesting. So first, the key part about it that is interesting is that Delta is 100% open. It sits in the Linux Foundation, and I don't mean like, well, we put it here, but the real version is elsewhere, or like one company drives it. You can see over 8 million monthly downloads happen on it, and you can just see that growth that's going up. So even in the early days, the amount of folks that are downloading it's significant. And the great part about this is that they say, look, it is open. It is kind of far more fully featured and performant than kind of any of the other formats out there. And the nice thing is that because Databricks is so heavily behind it, it is being tested on a regular basis at such significant diversity of workloads and scale that the pace of innovation and being improved and battle tested is significant. And so if we look at it, oftentimes we'll jump into the nuts and bolts, but if we ignore that for a second, what do you care about? Most of your users don't really care what's under the cover. Do we call it, Delta or some other water analogy or change? Here's what they care about. How good is my data reliability, right? I want high quality data in there. 2, I want basically like fast query performance. 3, I want to support all of the workloads. I don't want to think about for this type of workload this. And second, meet me where I am. Let me use the language that I want to use it, that I'm comfortable with, anything from SQL through Python. So how does Delta Lake deliver on this? Well, some of those details you see, it delivers full-blown transactions on any of the data that it comes in. So you're not worried about what happens if something partially fails. I can go look at previous versions, tons of advanced query techniques and indices and laying out. It allows you to bring streaming and batch together in one world, and has full first-class support for just pure Python and SQL, not some various dialects or deviations of it. And when you look at this performance versus, because people say there's other open data formats as well, is let's just use TP-CDS as an example. This is versus, many of the other formats out there, higher being better of the throughput. You could just see that it's not even close. And that bar is getting wider and wider as the, kind of innovation continues to pick up on Delta. So that is one, we are on the Delta side as that storage layer. Now, let's go to the next layer, which is where we're actually talking about governance, right? We mentioned security and consumability of how does that actually work. So one, the problem today is, and we started touching upon this, that it gets pretty complex across it. Because you have different personas. So you have data analysts, you have data engineers, you have data scientists, you'll even have, business users and the like. And then 2, you have data in these different places. Well, I've got a data lake, which is, I guess I need permissions on files. I might have this whole Hive source, so I need their tables and views. Data warehouses, I want tables, columns, and rows. And now it's not just data, it's other assets. Well, I need it on, for ML models, dashboards, or features. Well, as you see it on the data lake, there's no concept of tables or row and columns. On basically like this Hive metadata that you're storing, it could be out of sync with your actual data. Data warehouse is yet another data model. And then for when you talk about the other features like ML and data science, now you have yet another governance model. And just thinking about how do you think through all this and rationalize it is incredibly complex, right? So the notion of unity, and the name I have given away, is how do you provide one governance model for all of your data and AI assets? So as you think about it, to say, okay, it doesn't matter to me who the persona is, but I want this one catalog that regardless of where the data actually sits, it's just in there. And it's a simple way that I'm used to, right? What, database admins have been used to for a while. It's like, look, I can just use ANSI SQL grants and I'll put a UI on top of it. And I want this centralized auditing lineage, right? I want to understand who accessed what, how are my assets changing, where is that change coming from, and basically make sure that users can find what they need and consume through it really well. So the benefits of this, when you look at this Unity catalog, are that one, it's completely unified across, all of the different access models and all the different auditing across all of the clouds, right? Not one for AWS, one for GCP, one for Azure. Second, you talk about this is much faster, ability to get to the insights and discover data. And then a third important point is open data sharing and collaboration. So let's actually jump into that for a second of what does that mean when we talk about open data sharing, and collaboration, right? So many of the organizations now are saying, how do we actually take the data that we have and share it with basically the rest of the organization as one, and oftentimes with folks across into different organizations, as well. So in that element, the problem today when you do it is it's either something really, really kludgy, where you're going to take the data and create multiple copies of it, or you go and there's vendors that do it, but the vendors say you have to put the data in my proprietary data format, and everybody on each side has to use that same basically technology to go about and do it. And by the way, you're now limited to just what that, what my tool stack can do, which has oftentimes been just BI and data warehousing. So instead, built in this open spirit, what we talk about is having open data sharing and collaboration. So the nice part about this is, again, Delta sharing 100% open source, built in to basically the Delta sharing protocols built into Delta Lake says, you know what, as a data provider, I have all of this data, let's say that it's sitting in Delta Lake, and I have a sharing server that I run that I can provide sharing. So it's this one single auditing, notion. But now on the consumer side, there's such a wide set of folks implementing the protocol. So it could be that they have Databricks, or it could just be that somebody who just wants to use Pandas and Python, or a different, basically flavor of Apache Spark, or plug in their BI tools like Power BI and Tableau to it, or build an application around it. Any of these history of compatible clients can just take this together and be able to share data with each other, and you're just sharing existing data. There's no replication at all around it, and it's an open protocol. And the nice thing is that we won't talk about it as much today, but there's so many other things that are now built on top of this. So being able to secure this, right, with things like Unity Catalog, you have the concept of clean rooms. Or kind of a great part about this sharing is that for many of the data providers, there's now a data marketplace that they can go out and push, where those data sources, you can easily, your most common data sources, you can consume it from a wide variety of places and quickly get value out of it. So as you step back, you realize that ultimately our goal is to democratize data and AI, okay? And in order to experience this, for us, our destination is the Lakehouse. And I've spent a bunch of time talking about this Lakehouse platform. And so if we take one, step back and say, what is it that other organizations are seeing when we speak to them? There's a couple of things that we see that successful data leaders are looking for to reach the destination. One is, how do we simplify this existing architecture, to lower costs? And what I mean by that is, oftentimes people started with this world when we came to the cloud, and we're like, look, best of breed, we want a little bit of everything. We're going to have 50 things and we're going to use it together. And they realized there's a lot of technical debt to that. And it is actually fairly complex and hard to manage. So instead they look at, say, how do we start with a simpler set? Every tool, let's see how far we can take it, and only add additional tools when absolutely necessary, to start with the minimal about, so that there's not as much glue and friction points going in. So that's one. The second notion is that folks are realizing that governance is, foundational. How do I make sure that my data has high quality, right? How do I make sure that it's reliable? How do I make sure that I'm securing it and people can find it? Because otherwise what they realize, right, and this was the downfall, frankly, of the first iteration of the data lakes, it was like that garbage in, garbage out mentality. People couldn't find data. The data was really poor quality, so people stopped using it. So that governance as being foundational is key. And by the way, it's not just data. It's kind of all of the assets that are operating in there. And then lastly, when you look at it is, how do they migrate legacy stacks? I think one of the big challenges that we talk with folks is this concept that they get to where they're like, okay, I have all of this legacy pieces. The business is beating me up on it. It's not what they want. It's expensive. But look, it's going to be risky for me to go to the cloud. So I'm just going to lift and shift first. And then once I lift and shift, then I'll figure out how to optimize and modernize and get to kind of a proper architecture. Well, we all know how that movie plays out. One, no two environments are exactly the same. So that migration is going to be harder than you thought. It's going to take longer than you thought. And it's going to be more expensive than you thought. And so as a result, when you get there, nobody then has an appetite to modernize. And by the way, you haven't actually improved anything. You just moved it from one place to another without getting any of the benefits. So the real one is that they look at how do we build a plan that says we're going to go from point A and lift, modernize, and shift to that basically new architecture. So those are the three key things. From a Databricks perspective, we've obviously spent a fair bit of time today talking about kind of the technology and the platform. I mentioned people and processes are really important. So as we look at that, when we work with other organizations, it's how do we make this investment in you guys being successful? Because everybody's goal is saying, how do I get to that end destination as, with as little risk and as little cost and as basically quickly as possible? And so for us, it's beyond the platform. There's a bunch of things we think are critical to enable. One, we have a deep bench of technical resources that we are able to invest in, both directly and alongside partners to help make sure that you're successful. Two, tons around basically in-person and virtual, and oftentimes much of it free training options to help enable your team and think about that talent transformation to get there. And then finally, a lot of recipes and solution accelerators with us and alongside of many of our partners that basically say, instead of just starting from scratch, here's the recipe or template of how you get going faster on fraud detection or customer 360 or predictive maintenance or, kind of anti-money laundering and various ESG initiatives as well. And again, all of this obviously wrapped together under the banner of kind of like a 24/7, 365 global production operations to help you. So with that, hopefully, today we went through this understanding of why is everybody excited about bringing together data analytics and AI? Why do traditional approaches not work? And Lakehouse is now this core concept of where basically everybody is driving on that side is the right side of history. How do you determine kind of how these different lakehouses stack up, what's important, and giving you a glimpse of some of those technology underpinnings that show you the innovation that helps drive the success of Lakehouse and how Databricks can partner with you to make you successful. Thank you, and hopefully you enjoy the rest of the tour.